Welcome back again to the channel. On this video we're going to discuss the harmonic series, which is the sum of the reciprocal of the natural numbers. So the sum of 1 plus 1/2 plus 1/3, 1/4 and so on. Okay? And we would like to show that this series is divergent. And usually when this series is first time being introduced in the calculus book, it is proved by using some grouping of the terms of the series, and then we proved by this clever regrouping that the sum of some terms of this series can be bigger than any number that we can assign. So therefore, this sum is not convergent, or in other words, this series is divergent. Okay? But in this video, we're gonna use several results, which is given, of course, after we learn quite a bit about the convergence of several series. So one of the theorems that we are going to use is that if we have a series which is convergent, if this converges, then the partial sum is a convergent sequence, okay, to sum S. So Sn is the partial sum, which means that we are taking the n terms of this sequence and add them together. Okay? So actually this is just the definition. So this is not a theorem, but this is the definition of convergent series. So the series is called converge. We say that a series is convergent if the partial sum converges to some number. Okay, so that's the definition. So now let's call Hn to be the n partial sum of the harmonic series, and H2n is the 2n partial sum of this harmonic series, meaning we are taking reciprocal of 1, 2 up to 2n. So this one is 1 plus 1/2, so on up to 1 over n. Meanwhile, 1 over 2n is going to be 1 plus 1/2 plus 1 over n plus 1 over n plus 1, up to 1 over 2n. Okay? Suppose on the contrary that this series is convergent. So if star is convergent, then these two guys have limit, and their limit must be the same. Okay? Then the limit of n goes to infinity of h to n minus hn is equal to 0. Why? Because this sequence and that sequence converges to the same limit. Okay? Because this one is a subsequence of h to n. So, because both of them are convergent, then they have the same limit. Okay? But on the other hand, h to n minus hn, so if we subtract this guy from that one, so we just remove this part, and the remaining terms are 1 over n plus 1 up to 1 over 2n. Okay. Now, each of these is greater than, or smaller, I guess, smaller than 1 over n plus 1 over n plus, let's see what I'm trying to say. How to get something bigger if we divide with something, so this one is, let's say everybody here is bigger than 1 over 2n plus 1, correct? This guy, 2n plus 1 is bigger than 2n, so 1 over 2n plus 1 is smaller than this one, and definitely this one is smaller than this. So we have 1 over 2n plus 1. Okay, and there are n of them. Or if you want this to be less or equal, then you can just write this as 2n. Okay. So therefore, if we add all of them together, we have n of them. So n over 2n, which is equal to 1/2. And this is a contradiction, because if h2n minus hn is greater or equal to 1/2, and if that limit exists, then the limit of this must be greater or equal to 1/2. Meanwhile, here the limit is equal to 0. This implies that the limit as n goes to infinity of h2n minus hn is greater or equal to 1/2. And this is clearly a contradiction to the fact that the limit as n goes to infinity of h2n minus hn is equal to 0. It's a contradiction. Okay? And therefore, this series cannot be convergent. That series should be diverge. Okay, so that's all. A very quick video. Thank you for watching. See you again in the next video. Bye.